Guys, welcome back to TechDose, and in this video we will look at find the original typed string 2 problem, which is from Leetcode number 3333. You can solve this problem by using maths and combinatorics using the stars and bars technique, which I have already explained in 2929. But in this case we will be seeing the optimal solution using the dynamic programming technique. In this problem, Alice is attempting to type a specific string on her computer. However, she tends to be clumsy and may press a key for too long, resulting in a character being typed multiple times. So this line here suggests that a character will at least be typed one time, and it can be greater than equals to one time, right? You are given a string word which represents the final output displayed on Alice's screen. You are also given a positive integer k. Return the total number of possible original strings that Alice might have intended to type if she was trying to type a string of size at least k. Since the answer may be very large, we need to return modulo 10 to the power 9 plus 7. If you look at the first word, which is double A, double B, double C and double D, then the minimum sized string that Alice may have intended is every time she puts the finger on a unique character, it will be typed at least one time. B will be typed at least one time, C at least one time, D at least one time. So this is the minimum length of the intended string, and the maximum length is already the word dot size. The maximum length here is 8. So minimum intended length is 4, maximum intended length is 8. In this case, however, we are required to find out all the strings which are of length greater than equals to k. That means k must be greater than equals to 7, right? So in that sense, if all possible combinations contain 4 length string, 5 length string, 6 length string, 7 length string and 8 length string, then from these all possible combinations we need to remove the combinations which are less than k size. That means 4 to 6 must be removed so that we get the valid combinations, right? This is the idea for solving this problem. In this case, they have already mentioned all the possible string and the count is 5, therefore the answer is 5, right? I hope the problem statement is clear. Now in the constraint section, the words dot length, which is, let's say, value n, is less than equals to 5 times of 10 to the power of 5, and the word contains only lowercase English letters, which will be 26 in number, and k value maximum is 2000, which is 2 times of 10 to the power of 3, right? So if you write an order of nk algorithm, then it may or may not pass. It can be like touching the boundary of 10 to the power of 8. Now let's look at some observations. From this problem statement, we know that every unique character from left to right, when you move from left to right, is at least pressed once. So in this entire input string, let's say this is my given word. In this case, all the sequence of the same characters may have been pressed by mistake, but at least one time it will be pressed, right? So if there are 3 A's in a sequence, then a single A must have been pressed minimum. Okay, it can be 2 count, 3 count as well, but minimum 1 count. Similarly, double B will be reduced to single B, 5 C's will be reduced to single C, and 2 A's will be reduced to a single A. We will call this a run of same characters as runs. Okay, so this is run 1, run 2, run 3, run 4. So if you want to find out all possible combinations of string that you can form by including at least one occurrence from each of the run, then that will be equals to the multiplication of all of the run length, which is 3, 2, 5 and 2. So if you multiply 3, 2, 5, 2, that will be 60. So there will be 60 possible strings of minimum length 4. The length can be greater than equals to 4, right? Of minimum length 4, where each of the runs at least one character is included and the sequence is maintained in the same order, right? So the count will be equals to 60. This is case number 1, where the question is asking about a given value k, which is less than equals to the total number of runs. Here the total number of runs are equals to 4 runs. 1, 2, 3, 4, right? Now if the question would have asked about produce all possible strings where at least each of the runs one character is included, and let's say the k value was 3, then in this case, since the minimum string length was 4, then the total combinations will contain all the string length which is greater than equals to 4, right? The length will be from 4 to the entire length of this string, isn't it? So since the k value, if the k value happens to be less than equals to the number of runs, in this case 4, then the answer will always be equals to the valid combination count will be equals to the total combinations, because there are no invalid combinations. Another case, which is case 2, will be when let's say k equals to 6, then in this case we are asking about producing all those strings where the length is minimum 6. So that means you produce all possible combination and it will be having all the length 4, length 5, length 6 and so on till the word dot size length, and from this we need to remove the 4 length and 5 length in order to get all the valid sequence, isn't it? From the total combinations, calculate the invalid strings, remove it to get the valid string. That will be your idea for case number 2, where if k is greater than r, then the valid combinations will be total combinations minus invalid combinations. I am taking the same example here and I am showing for k equals to 6. As I had explained, the total combinations is combination of length 4, 5, 6 and so on till the length of the entire word. And in that case, if I am talking about k to be 6, then I will be removing all the invalid length sequences to get all the valid strings. So I will calculate valid combinations equals to total combination, which you can get by multiplying all the run lengths. You know that already. Okay, 3 times 2 times 5 times 2. This will be total combinations where each of the runs character is included at least one time, which will lead to minimum length string or more than that, subtracted with all the combinations with length less than the given k value, right? So these are the only 2 cases. There will be no other case. Now let's see how to count the given combinations in case where k is actually greater than the number of runs. Okay, because if k is less than equals to runs, then you can simply multiply the occurrences to get the result, isn't it? So our main focus will be to calculate when k is greater than the number of runs. In this case, the number of runs are 4, k value is 6. So we need to get the count of length 4 combinations, because you know that the minimum length string here is going to be A, B, C, A. So how many strings can be produced with length 4? Only one string. So one combination. How many strings can be produced with length 5? Now for length 5, you can include this A multiple times. You can include this A 1 time, 2 times. Can you include this A 3 times? It will not be possible, because if you include this A 3 times and you need to produce a 5 length string, A is included already 3 times, then B, C and the last run must also be included 1 time, right? So the length will not be 5, the length will become 3 plus 3, which is 6. So that is why you cannot include 3 A's, you have to include only 2 A's, isn't it? So these are all the possible combinations that we can form. For the same reason, let's say that you had included 1A, 1B, then how many C's can you include? You can include 1C or 2C, but you cannot include 3 or more C's, because if you do that, then the length will exceed 5. Okay. So I hope you have got an understanding, and if I have one combination of length 4 and 4 combination of length 5, then I will get the valid combination by subtracting the invalid combination from total combination, and the answer will be 55 in this case. Okay. So now you have got an overall idea of what we are trying to do. So let's see a recursion tree diagram using which you can actually write the recursion code to run this entire idea using recursion. So the combinations of length less than k has to be generated so that we get the count of all the invalid strings. Let's say this is the given word and the k value is 6. The minimum length of the string in this case is 3, which is ABC. So the number of runs are 3 in this case, right? The number of runs will decide what is the minimum length. So the mandatory minimum length is 3. Therefore, we will be counting only 3, 4 and 5 length string because k value is 6, so that we get all the invalid combinations, isn't it? So any run can have the frequency range by considering 2 factors. The first factor is taking at least one occurrence of each run character. That means if A is the run, then at least one time A has to be included. If B is the run, whatever is its length, at least one time it has to be included, and same goes for C as well. Okay. And the length must always be less than equals to K so that it is an invalid combination. Let's try to generate all the invalid combinations using recursion. So this is the recursion tree diagram. Okay, recursion tree diagram. In this case, I have not shown you any of the invalid strings. This recursion tree diagram only shows you the valid string, but you can also go ahead and expand this recursion tree diagram to include the invalid strings as well. So in this case, if I try to include A, how many options do I have for A's frequency? I can include A 1 time, 2 time, or 3 time. 1 time, 2 time, or 3 time, isn't it? That is up to us how many times we include. But we should always make sure that while adding up the length, it should never be greater than equals to K. The length must always be less than K at any point of time, whatever number of items I take. So let's say A is taken 1 time. Then after A, I will go to B. So B has 4 frequency. How many times B can be included? Can it be included 1 time, 2 time, 3 time? Yes. But can it be included 4 time? Well, absolutely no. If you included already A 1 time, and if you include B 4 times, even though the frequency supports that B can be included 4 times, you have to include C at least 1 time, and so the length will become 6, which is not less than K, right? So that is why I have not shown you the branching for 4 here. But if you want to write the typical recursion tree, then the 4 will also be included. Okay. So I'm just trying to show you the paths which will be actually producing the string we are interested in. Okay. Otherwise it will take a lot of space in this figure. I hope you understand that. So at B, I can include it 1 time, 2 time, or 3 time. Let's say B was included 1 time, then C can be included 1 or 2 time because of the frequency, and also one another thing to check is the length must always be less than K. Instead of this being less than equals to, length must always be less than K, right? Okay. So if you follow this entire recursion tree diagram, then I have written all the combination that you get, and I have also mentioned all the combination of strings that you can generate. Okay, I don't need to save these strings because it is not asking us to return the strings, but I have to just take a counter assigned to 0 and just do count plus plus whenever you reach to the end of the string. If the length is less than K, then it is fine, isn't it? So these are the count of invalid combinations. What will be the count of total combination? Run 1 length multiplied by run 2 length multiplied by run 3 length, which will be 3 times 4, 12 into 2, 24. The invalid combinations are 9. So the valid combination will be total combination minus invalid, which will be 15. Okay. So this is how you can actually apply your idea of solving this problem by recursion. Now, having looked at the idea of recursion, let's now understand about how to count the total number of strings that we can get with a particular length. So what we are trying to do is we will be trying to divide all these runs as R1, R2 and R3. We are not interested in what characters are present, but we are just interested in the run length. The first run length is 3. Okay. Now I will be trying to first use only the first run characters, that is AAA, that which is of 3 length, and try to find out how many strings can I produce of different length from the string length being 0 to 5. Why I have taken from 0 to 5? Because I want to generate all the string lengths which are less than K. That is why I have taken from 0 to K minus 1. You can say from 0 to K minus 1 I have taken. Okay. The idea here is to take the first run and find out how many strings can I produce. So in this case, how many string of 0 length can you produce? Let's say that the count is 0. For 1 length, how many strings can you produce? You can produce exactly 1 string by taking just a single A. How many can you produce of 2 length? Actually only 1 string, which is by taking double A. Okay. Because if you take the first 2 A's or the last 2 A's, it does not matter. They both are identical. Okay. The position will not matter. When you think about 3 length, then you can take 1 string which is AAA and make it out of this string which is AAA already. Can you make a 4 length string? No. So let's write the count to be 0. Can you make the 5 length string? No, because the length of the string of the first run is AAA, right? So just by taking a string AAA, let's say our entire word itself was AAA, then I'm trying to find out how many strings can I form of length 0, of length 1, of length 2, 3, 4, 5. Of length 0, you can say that I can form one string, right? We can say that I can form one string if the entire string is empty. You can form it in one way. But other than that, from string length 1 to 5, you can form it in one way for 1 length string, one way for 2 length string, one way for 3 length string by including A, double A or triple A. And for 4 length you cannot form because this length itself is less than 4, and for the same reason for 5 it will be 0. Now for 0 length the case will not happen, because if you look here, the word length is at least 1. So 0 length will never happen, right? And if the word has at least a single character, it must be included. Therefore, this holds no significance for us, the 0, right? Now, after processing for this first run, I will try to include 2 runs. I will try to include the second run on top of the first run. So, my string will be AAA and 4 Bs. And now let's see how many count of string can I form of a particular length from 0 to 5. Okay. Now for 0, let's keep it 0. Okay, let's keep it 0. For 1, what should I write? For 1 length, is it possible to make a 1 length string by having 2 runs? It will be impossible, because if you have 2 runs, now you have AAA and you have 4 Bs as well. If you have 2 runs, at least 1 character should come from first run and at least 1 character should come from the second run. So a 0 count will be added until you reach to a minimum length, and the minimum length is 2 here if you include 2 runs, right? So 0, 0 for 0 and 1. Only from 2 I will start to fill here. And what will be filled at this position? If you have let's say 2 length, then what will I do is, for 2 slots, if you are looking at the second run, then you can choose to put 1 character here, and the rest of the characters to the left will be filled by all possible ways from this AAA, which is only one way, right? Only one particular string can be present. Or you can choose to place double B and all the left hand side characters will be pushed by A. But is it possible to push double E and you have A's to the left of it? Well, there is no more position, right? So you cannot push double B. You have only 2 position, and you know that minimum 1 time this A has to be included. So there is only one way, which is AB. Okay, which is AB. So I will be writing 1. Okay, I'll be just writing 1. Now if you have 3 slots, let's go to 3 slots. Then what you can do is, you can fill this with B and fill the left hand side with all possible ways to place the A's, or you can place this with double B and place this with A, right? You cannot place this with triple B, because then A cannot be included. So how many ways were we able to do it? In 2 ways, right? How do I know that it will be 2 ways? In this case, if you have 3 slots, if in the third slot you pushed B, then in the rest of the slots from 1 to 2, whatever number of ways you can place A, that is 1 plus 1, you can just add these values 1 plus 1, which is 2, and you can write it here. Okay, that is how you can solve this anyway. For 4 length, let's say that you have 4 length, 1, 2, 3, 4. You can place 1B and place all the A's on the left hand side, A. Or you can place 2 B's and place all the A's on the left side. You can place 3 B's and place all the A's on the left side, and these are the only possible combinations. So if you place a B at the 4th location, then you can place all the A's from 1 to 3. Or if you place B at the location 3, 4, then you can place all the A's at 1 to 2 and so on, right? As I have shown here. So it will be equivalent to getting all possible ways to fill 3 slots with just A's run, 2 slots with just A's run, and 1 slot with just A's run. Okay, so you can just add these values and write it here 3, right? And for 5 length, let's say 1, 2, 3, 4, 5 is present. Then for the same reason, you can have 1B, 2B, 3Bs, and you can have 4 Bs, because Bs, I mean, definitely you cannot exceed the maximum frequency of B, which is 4. So in this case, in how many ways A can fill up a 4 length slot? It can fill up in 0 ways. In how many ways? Because there is only 3A. With the 3 number of A's, how can you fill 4 slots? It is not possible. So this is invalid. In how many ways can you fill 3 slots with A's run? 1 way. In how many ways can you fill 2 slots with A's run? 1 way. And in how many ways can you fill this 1 slot with A's run? 1 way. So you add it up, and this will also be 3. Right? So I hope you are understanding that we are adding the numbers in a range all the time. If you notice here, let me do the third run as well, and then I will show you. In the third run, when you are including C as well, then minimum you have to include one character from all of them. So until you reach to length 3, everything should be set to 0, because it will not be possible to get a smaller length valid string, isn't it? Now only from length 3 it will be possible. And if you look at length 3, you will have 3 slots. How many C's can you take? Even though there are 2 options, you can take only 1, because a B and A has to come on the left side. So there is only 1 way. And how do you find it out? Because at 3, if you place a C, at this point if you place a C, let me just clean it up. At 3 if you place a C, then at 2 you see that the value is 1. That means including the first 2 runs, you can fill up the first 2 slots in 1 way. So just append a C here, and so there will be 1 way. Okay. Now if you look at this 4, if you have 4 slots, 1, 2, let me write it here, 1, 2, 3, 4. So you can place 1C or you can place 2C. Both will be valid. So if you place 1C, then the problem reduces to how many runs are there to the left? A's and B's run, right? So there are 2 runs. So with the 2 runs, in how many ways can you fill these 3 slots? With the 2 runs, how many ways can you fill the 3 slots? 2 ways. Plus, if you have 2 slots left on the left hand side, then in how many ways can you fill this up with 2 runs? That is 1 way. So 1 plus 2 is going to be 3. So that is why the answer is 3 here. Okay. If you have 5 slots, 1, 2, 3, 4, 5, then C can be placed here 1 time. So using 4 slots and A's and B's run, in how many ways can you do it? 3 ways. Okay, 3 ways. Plus, if you place 2 C's, then in how many ways can you actually place A's and B's run with the 3 slots? 2 ways. Okay, so add 2 to it. And can you have more C's? No, because C's frequency is only 2. So how many ways are there? 5 ways. So you will write 5 here. Okay. After all the 3 runs, whatever you get here, if you just add it up, 1 plus 3 plus 5, that will be equals to 9. This will give you the total number of combinations which are of length less than k, and that follows the constraint that each of the runs character is included at least 1 time. Okay, so these are all the count of invalid combinations. What are the count of valid combinations? There are first run length, which is 3 times, second run length 4 times, and the third term length, which is 2 times. Okay, the run length. So this is 24, and therefore the valid combinations are going to be 24 minus 9, which will be 15. Okay. So this is how we will calculate. Now if you have noticed in this problem, then if we have certain number of slots, let's say we are talking about the ith slot, and if we are trying to place a certain character, let's say that I am trying to place a C here, I am trying to place a C, then I can place the C frequency number of times, isn't it? So I can place it 1 time or 2 time. I should place it in such a way that the entire string becomes valid. In such a way A and B are also included 1 time, right? So let's say that I can place 1 or 2 time. If you place 1 time, then the problem reduces to in how many ways can you fill the rest of the slot, that means 4 slots, by using the previous runs, 2 runs. And if I place double C, then in how many ways can you fill the 3 slots by using the 2 runs A and B, right? So this is equivalent to adding the values at 3 and 4. And how did I get the values? Why did I know that it will be the addition of 3 and 4? Because you know that at 5th position, if I'm trying to fill it up by C, then how many frequencies of C are present? 2 frequencies are present, right? So if two frequencies are present, then maybe C will be placed here one time, or it may be placed here two times, isn't it? So I will be always interested in the sum of the numbers that I have counted, frequency of C number of times to the left. How can I get it? You can just iterate over it and add it, or you can maintain a prefix sum in such a way that the prefix sum will always tell you in the range of L to R. If you want to get the sum, you can do prefix sum at R minus prefix sum at L minus 1, and that will give you the sum in the middle, right? So prefix sum will be optimizing our solution. So we will be solving the same problem using prefix sum, and in this case I am taking proper naming, and K is actually, you can say, the length. Okay, so 0, 1, 2, 3, 4, 5 are the lengths that I am interested in counting, because K value is 6. So I am trying to count all the strings that follows all the constraints but are less than K size. The given string is present. What will be the minimum length string? It will be just ABC, which is 3 length. Now in this case, the count at I equals X means that we can get X number of strings of length I after any run, which was the same thing which I had shown here. The 2 here means that if we have 3 slots and we have the first 2 runs, then I can fill it up in 2 ways. That is the meaning of it, right? That is the same thing which the count will be doing. Now in this case, I will be maintaining an extra prefix sum because I want to do that range addition in O1 time. Okay. Before starting, I will be setting the counter with a value of 1 for 0 length, assuming that if I have to form a 0 length string, then it can be formed in one way, and for the rest of them it will be 0, saying that it cannot be formed. Okay, because we don't know anything. And if I calculate the prefix sum over it, the prefix sum is going to be 1. Prefix sum is going to be 1. Now I have also taken a new count, and this new count will be storing all the updated values of count. Okay, you will understand at the end why it is important, but let's assume that it will be storing the updated values of count. You can assume that if none of the values are filled here, it is all equals to 0. Okay, all the values are equals to 0 if I have not filled here. Let's try the first run, which is run number 1, triple A. Now let's try to find out the first length string, that means one length string. How many of them can you form with just one run? You can form it equals to, if you have just one slot, then in how many ways you can form? You can just form in one way. In this case, what will you do is, you will see that you will be filling it up by A, it is at location 1. So on the left hand side, if you had one less run, then in how many ways can you fill up zero slots? That means in how many ways can you form empty string? In one way you can form it, right? One way. Therefore you have to write 1 here, which could have been calculated by finding the prefix sum at I minus 1 minus the prefix sum at I minus 1 minus the frequency of this run. Now you will find that I minus 1 minus frequency will be, in this case, 1 minus 1 minus 3, which will be minus 3. So since a negative index is not accessible, so in that case, you know from the prefix sum rule that if something goes out of bound, you have to just take it with 0, right? Simple prefix sum technique. And that is what we will be doing. We will be just seeing that if this index is minus 1, then this entire value will become 0. Okay. So I hope you already know prefix sum, so I will not be focusing on it too much. Let's try to do the dry run. So in this case, the value will be 1 here. Now if I go to length 2, okay, then I have 2 slot and I want to fill up the second slot with A. Okay, with A. So you can fill it up with A, and in how many ways can you fill up the first slot with no runs? 0 ways. And if you fill up the first 2 with A's, then in how many ways can you fill up no slot with no runs? 1 way, right? So here also you will get 1 way. And how do you get it from the prefix sum? You get it as prefix sum at 1 minus prefix sum at what is the index? 2 minus 1 minus 3, which will be minus 2. That means you can just ignore this value. So prefix sum at 1 is 1, and that is why this will be 1, right? Now let's go to this 3 slots. If you have 3 slots, then you can choose to place A here. So in how many ways can you fill 2 slots with no runs? Because this is the first run, right? 0 ways. If you place 2 A's, then in how many ways can you fill the first slot with no runs? 0 ways. And if you place 3 A's, I can place 3 A's because the frequency is 3, right? If you place it with 3 A's, then in how many ways can you fill 0 slots with 0 runs? 1 way. Therefore, the answer will be 1 here. And how do you calculate it from the prefix sum? You are looking at index 3. So you see I minus 1th index, that means the value is 1, and I minus 1 minus frequency, which is 3 minus 1 minus 3, which is minus 1. So if it is negative, then you ignore it and the value is 1. That's why it is 1, right? If you go to 4 slots, then 4 slots will not be possible, because if you place an A or whatever, you cannot have 4 A's because the frequency is 3 only, right? So that is why it will be 0. And how do you know? From the prefix sum. You see that the index I is 4. So if you calculate prefix sum at I minus 1, this is 1. I minus 1 minus frequency will be 0, which is 1 here again, and 1 minus 1 is 0, and that is why it will be 0. For the same reason, 5 length will also be 0, right? Okay, so this is the updated count. So if I had done the first run, if you look at the first run here that I had done, the updated value will be 0 1 1 1 0 0. And let's say, what is the meaning of this second index value being 1 in the first run? It means that if you just had the string AAA and if you had to fill 2 slots, then in how many ways can you fill it up? You can fill it up in only one way, which is by using AA. That's it. No other way, right? That's the meaning. So we have just done the same thing. And now if you remember, in the second run, this first run was taken as the input, as the base, isn't it? So that is why this new count will be actually stored in the counter, and I will replace the name with count. That is the significance of it, so that it will be used as a count in the next run. Okay, in the next run. And this value will be 0, because I said that if I have not filled it up, it is 0. And then again we will be taking a new count. This was your run number 1. This will be your run number 2. So let's try to fill it up. 0 1 2 3 4 5, and this is going to be your array, and all the values will be 0 initially. Okay, all the values are going to be 0. The prefix sum will also be updated, and let's try to make this array 2. It will be 0 1 2 3 4 5, and it will be updated from the new count values, which will be 0 here, 0 1 2 3 3 3, from these values. Okay, 0 1 2 3 3 3. Okay, now let's repeat it, and at this point of time we will be having 2 runs. We will not just be having 1 run, we will be having 2 runs. So let's see how to do that. If we have 2 runs, we have AAA and 4 B's. Okay, and we are looking at the second run, which is for B's run, right? So for 0 length we will not be considering. Can we do anything with one length? You know that with 1 length, if you have just 1 slot, how can you place 2 runs? It will not be possible. At least the minimum length should be equals to the number of runs. So in this case, I will be writing 0 here, right? It will be 0. Okay, and how do you know it will be 0, right? You can also use the prefix sum array, and you can say that I minus 1 to I minus 1 minus frequency, which is going to be negative. So you can just leave it out and it is going to be 0 for sure. Okay, let's go from index 2. Index 2 means you have 2 slots. So what you can do? You can put either 1B or 2B's, but 2B's will be invalid because an A has to be put on the left side. So in how many ways can you fill this up? Like if you place 1B, then in how many ways can you fill up 1 slot by using only run 1? How do you get it? 1 slot with 1 run, 1 slot with 1 run. I mean run number 1, right? After run number 1 you got this array, so 1 slot can be filled in 1 way. Okay, and that is why you will be writing 1 here. How do you calculate from the prefix sum? You can calculate prefix sum at I minus 1 minus I minus 1 minus frequency. I is 2, so 2 minus 1 minus frequency is going to be a negative value, which is minus 5 plus 2 minus 3. So I will ignore the left pointer and it is going to be 1. You can write 1 here. Similarly, if you have 3 slots, how do you calculate it? You can calculate it by seeing the prefix sum at I minus 1 minus I minus 1 minus the frequency, which is again going to be negative minus 2. So you can ignore it and write the value 2 here. And simply for this 4, you can take 3 and the and now the left pointer, which is I minus 1 minus frequency, is going to be minus 1. So just ignore it, write 3 here. For this 5, you can write 3 and the next index is going to be 0. At 0 you have 0. So 3 minus 0 is 3. So that is why you can write 3 here. This is the faster way to write it. We are now using the prefix sum. Since you have already understood it, so I am not explaining it too much right now. And we are done with the second run. Now for the third run, we have to again take the prefix sum, new prefix sum, right? 0, 1, 2, 3, 4, 5. Okay. And this will be the new counter. So this is the new counter. Okay, updated counter you can say after the run 2. Run 2 is done. Now for run 3, we are trying to calculate, and so I will be taking the new counter again, and this will be initialized to 0, 1, 2, 3, 4, 5 with all the values being 0. Okay, I'm not filling the values, but it means that it will be 0. The prefix sum will be calculated by moving from left to right. That is going to be 0, 0, 1, 3, 6, 9. Okay. Now let's see. Now you are doing for 3 runs. So 3 runs means your string is this entire string, and we are looking at this C run, which is the run number 3. So if you have 3 runs, at least you should be looking at length 3. Everything below length 3. That means if you have less than 3 slots, then how do you accommodate 3 unique characters? It will not be possible. So to the left of 3, you will have all the zeros. Okay. And now from length 3, you try to calculate it. What is the frequency? Frequency is 2 only. So if you have, let's say, 3 slots, and if you have to place C, you can place 1 C here, or you can place 2 C's here, right? So can you place 2 C's? You cannot, because from one slot, how can you fill one character at least from A and one character from B? It will not be possible, right? So let's say that you have placed a C. Then the problem reduces to filling the 2 slots with the first 2 runs. That means filling the 2 slots from the first 2 run is giving you 1 count. Therefore the answer will be 1 here. But how do you calculate from the prefix sum? It will be prefix sum at I minus 1, which is 1. Okay, I minus 1. What is I? I is 3. So I minus 1 will be 2. And I minus 1 minus frequency. That means I minus 1 minus frequency will be what? 2 minus 2, which is 0. So at 0 you have 0. So 1 minus 0 is going to be 1. So write 1 here. Simply for this 4, you can write 3 minus 0, which will be 3. And for this 5, you can write 6 minus 1, which is going to be 5. Okay. So after run number 3, this is the counter. If I look at count at 4, after the 3 runs, then it is giving me 3. This means that if I had 4 slots, and if I had this entire string, which has 3 runs in it, then in how many ways can you fill these 4 slots? There will be 3 ways. Okay. So that means there will be 3 strings possible, which is of length 4, which is following our constraint that each of the runs minimum one character has to be included. Okay. So the strings from length 0 to less than k have been calculated. Now you just need to add it. So you can accumulate or add all these values. That is going to be 1 plus 3, 4 plus 5, 9. How to find total combinations? Take the run 1 length, take the run 2 length, and take the run 3 length, which is going to be 24. So subtract 9 from 24 and the value will be 15, and the total valid combinations is going to be 15. And that is how you calculate the answer, right? So I hope this entire approach is clear. In this case, we are iterating over the entire string and finding the runs, which is order of n. And on top of that, if you have calculated the runs to be, let's say, r number of runs, then in that case, for each of the run, we are doing this entire process of size k. The count and p sum are of size k, right? So the total complexity can be assumed to be order of n plus rk. But r, the number of runs, can be equals to n in the worst case, because each of the unique characters can be present in this way, right? Where every character is unique, no 2 adjacent characters are same. So r can tend to n, but this can be the time complexity, and so I have written order of nk. And the space complexity will be order of n plus k, because you see the k size, count, new count and p sum are used, so 3 times of k, and I don't think any other space is used, so that is n plus k. Okay, the number of runs are stored in another array which is of size number of runs, and number of runs can be n, and that is why the n was added. I hope the time and space is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the word and k, and step 1 is to make the runs array. So I will be iterating and finding out all the adjacent characters. If they are equal, then just increment the frequency, otherwise increment a new run with frequency 1 count. Once you have calculated the runs, then we will be calculating the total combinations, which will be just multiplying all the run size, and take always mod of 10 to the power 9 plus 7 as mentioned in the question. This is case number 1, where the run size is greater than equals to k. Then in that case there will be no invalid combinations, everything would be valid. So I will be returning the answer from this line number 18. But if the k value is greater than the runs dot size, then we have to apply dynamic programming over it. And in the dynamic programming step, that count at I, v being x, for let's say the third run, means that x is the number of strings that can be formed of length I using the first 3 runs. That I have already explained you in detail. Now let's take the 3 arrays that I was talking about, count, new count and prefix sum, all of size k, and count at 0 will be 1. That means one way to form an empty string by not including any character. And the step number 3 is to count the number of strings of different sizes formed by including all the runs using dynamic programming. So in this case I will be iterating through all the runs one by one, and I will be just doing for the first run initially, and for the first run the prefix sum at 0 will be count at 0 whatever it is, and I will be iterating from 1 to less than k and simply update the prefix sum. This is very simple, right? After updating, you need to make a run, and what you do is you start from 1 to k, find the right side, that means prefix sum at I minus 1, and the left side assigned to 0. If the left side is within the bounds, that means greater than equals to 0 index, then also take some left value. This is nothing but doing the range sum using the prefix sum from L to R. Okay, this is the R value and this is the L value. You can just use pen and paper and it will be clear. Now you know that since it is a modulo function, the right minus left can also become negative, and that is why we can add mod and take the entire thing with the same mod function. It is the same thing as if you want to calculate 2 mod of 5. Whatever is the result, you can also add 2 plus 5 and take the mod with 5 to get the same result, right? This is the simple modulo arithmetic. After one run, we know that the new count will be assigned with the count, so we will be swapping it and filling all the new count values with 0. And after doing it for all the runs, once we come out, then we will be counting how many invalid combinations are there by just adding up all the values in the given count array and always taking mod with the given 10 to the power 9 plus 7, and then return all the valid combinations by subtracting total combinations minus invalid combinations plus mod of 10 to the power 9 plus 7, right? So I hope this entire approach is clear. You can contribute and help us in making this free content possible by joining our channel. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. See you guys in the next video. Thank you.